Here is a combined summary of the 2 pages. ShinyItemAnalysis, SIA, is an R package and Shiny application for interactive presentation and analysis of psychometric methods in psychology, education, and social sciences. The recent version of the package introduces SIAmodules, allowing researchers and practitioners to develop add-on extensions for broader use. These modules integrate with and build upon the SIA interactive application, leveraging existing infrastructure for tasks such as data uploading and processing. They can access a range of outputs from various analyses, including item response theory models, exploratory factor analysis, or differential item functioning models. In social sciences, measurement involves latent traits, error, and multiple raters and/or multi-item instruments. Consequently, statistical and psychometric models and techniques have been developed to analyze such measurements, including providing proofs of measurement reliability, assessing validity, and analyzing internal structure with factor analysis. The SIA-R package was developed to provide helpful functions and an interactive platform for analyzing multi-item measurements. The interactive SIA application serves as an entry point for newcomers to R, offering access to various sample datasets and the ability to upload and analyze data. The psychometric analyses within the application are structured in sections, aligning with the workflow outlined in the standards and more closely described by Martinková and Hladká, 2023. The application also offers the automatic generation of PDF and HTML reports, which may help incorporate psychometric analyses into the test development process. The introduction of SIA modules enables users to extend the analyses and functionalities of the SIA application, empowering researchers and practitioners to develop add-on modules that seamlessly integrate with and expand upon the capabilities of the main application. The SIA modules are designed to integrate with the existing SIA infrastructure, leveraging the existing infrastructure for tasks such as data uploading and processing. The SIA application provides a comprehensive framework for multi-item measurement in social sciences, encompassing core psychometric models and methods for evaluating measurement validity and reliability. The application allows users to integrate additional analyses and advanced approaches through SIA modules. Measurement validity is assessed through various statistical models, employing quantitative evidence from different sources, such as correlation coefficients, t-tests, analysis of variance, or regression models. The internal structure of the test is examined through factor analysis, while reliability is evaluated through internal consistency, correlations between items or subscores, and variance component models. Item response analysis is crucial for developing multi-item measurements and understanding respondent traits. Traditional item analysis uses proportions, percentages, and correlations to describe item functioning, but its inference is limited. Regression models, on the other hand, allow for the estimation of item characteristics by interlacing empirical values with respect to the observed ability. Item response theory, IRT, models provide a more precise description of item functioning by simultaneously estimating latent traits and item parameters, but at the cost of increased computational demands. The 3-parameter logistic, 3 petaliters, model is a common IRT model, which estimates the probability of a correct answer or item endorsement based on a person's ability. The model parameters, such as the intercept, slope, and lower asymptote, describe the item characteristic curve. Alternative parametrizations, such as the 2 petaliters IRT model or the adjacent category model, can be employed to account for different types of item responses. The SIA application provides a flexible and comprehensive framework for item response analysis, allowing users to integrate various models and approaches to evaluate measurement validity and reliability. The research paper discusses the application of logistic regression and item response theory, IRT, models in educational testing. It highlights the importance of understanding the strengths and weaknesses of tested subgroups through differential item functioning, DIF, detection. The paper also explores the use of computerized adaptive testing, CAT, for efficient measurement. Logistic regression models are used to describe the functioning of items in educational tests. These models can be extended to account for different item types and to include possible guessing or slipping when answering. Item parameters in logistic regression-based models are typically estimated via the maximum likelihood method. IRT models, on the other hand, can also be used to describe item functioning. These models are often fitted simultaneously for all items, providing a more precise estimate of the latent ability. IRT models can also be used for DIF detection, where item parameters are estimated separately for two groups and then scaled. DIF detection is crucial as it helps identify potentially unfair items. Traditional approaches include the delta method, the Mantel-Heinzel test, and SIBTEST. Logistic regression methods can also be used, incorporating the effect of group membership variable and its interaction with the matching criterion. IRT models for DIF detection involve fitting models separately for two groups and then scaling item parameters. Computerized adaptive testing, CAT, employs IRT modeling within an iterative algorithm to provide an efficient measurement. In CAT, a respondent's ability estimate is updated after each answer, and the next item is selected as the most informative and suitable item for that ability level from a pool of pre-calibrated items. This process is repeated until termination criteria are met. The paper provides insights into the strengths and limitations of various models and methods used in educational testing. It emphasizes the importance of understanding the functioning of items and the potential for bias in educational tests. The use of CAT is also discussed as a means to enhance the efficiency of testing. Overall, the paper offers a comprehensive overview of the application of statistical models in educational testing and highlights the importance of DIF detection and CAT. The research discusses the evolution of computational psychometrics, focusing on advanced topics such as item wording analysis and automatic item generation. It highlights the use of text analysis and natural language processing to estimate item difficulty. Measurement models like IRT are also encompassed in structural equation models, SEM, for analyzing relationships among variables. The SIA application, developed in R, leverages the Shiny package for interactive analysis. It includes modules for item analysis and text analysis, which can be extended further by installing additional modules. The architecture of these modules is based on Shiny modules, consisting of server logic and user interface functions. The modules are distributed as R packages and can be integrated into the SIA application upon launch. The discovery and usage of these modules involve collecting a list of packages claiming to contain SIA modules from the user's library. This setup enables the creation of new modules that bring these advanced topics to a broader audience. Here is the combined summary. The SIA module packages are loaded and attached using the standard library call, ensuring that any non-trivial features, such as compiled code or S3, S4 methods, work as usual. A reference to the namespace environment of the currently loaded module package is kept in the NS object. The YAML file of each module package is then searched for the module's metadata and function bindings. The server function of each module is located within the package's namespace environment and invoked using do call, with the module's unique identifier as the first argument and with a list of SIA's reactive val, and reactive values as the second argument. This enables the module to reuse any reactive object present in the parent application. The UI of the module function is called in a similar fashion, but inside Shiny's append tab, function that appends a new entry to the correct menu. The category specified in mod_desk $category within the module's metadata is used to place the module tab in the desired menu section of the application. Currently, available categories include scores, validity, reliability, item analysis, regression, IRT models, and DIF, fairness. To streamline the development of new SIA modules, the SIAtools package is introduced, comprising a collection of functions for constructing and managing modules, along with ready-to-use templates, guides, and various tests to ensure a smooth integration of the module into the SIA application. Developers can focus solely on the content of the module itself, and still retain the option to create SIA modules from scratch. The SIAtools package offers the capability to create an R package serving as a container for the SIA module. Developers can utilize the add_module function to configure the package to be compatible with the SIA application, which automatically generates an entry in the YAML file and creates a template tailored for a new SIA module. The YAML file contains the module specification, including the title, category, and function bindings. The automatically generated module ID serves as the identifier for the module throughout the application. The research paper discusses the development of a computerized adaptive tests (CAT) module, focusing on the user-facing documentation and the UI function definition in the SM_CAT R source file. The documentation provides an overview of the module's purpose and functionality, enhancing clarity for users. The UI part is dedicated to defining components and layout using functions from the Shiny package. It includes a Level 3 heading, an input element for selecting an IRT model, a slider input for adjusting the true ability of a respondent, and a plot output. The code snippet showcases the implementation of these components, emphasizing the importance of using the NS function to wrap UI elements. The module's example documentation highlights its purpose as a simplified version of the CAT module, demonstrating basic principles of module development. The paper also references a publication by Doe, 3024, for further information on the module. The SIAtools package provides a framework for creating interactive computerized adaptive tests, CATs, within the R environment. It leverages the Shiny framework to build web applications that can be used for educational assessments and research. The SM_CAT R source file contains the UI and server logic for a sample CAT module, which demonstrates how to integrate IRT models and simulate CAT administration. The UI function defines the layout of the Shiny application, including input fields for selecting an IRT model and a slider for setting the true latent ability. The NS function is used to ensure that UI input and output IDs match with their server logic counterparts. A linter compatible with the linter package checks for the omission of this name spacing practice. The server logic, defined within the SM_CAT_server function, utilizes reactive expressions to create a dynamic simulation of CAT administration. It first determines the IRT model based on user input and then generates a response pattern using the true latent ability selected by the user. The MERT-CAT package is used to simulate the CAT administration, stopping when a minimal standard error of 0.40 is reached. Finally, a plot of the post-hoc simulation is generated using the plot method of the MERT-CAT package. To preview the work in progress, the preview_module function can be called, which loads and attaches the entire package without requiring installation. This function utilizes Roxygen 2 blocks to automatically convert into road manual files and namespace entries. The module's functions are called within a simple Shiny application skeleton, and upon execution, the application launches. However, if an error message is displayed when selecting another model from the SIA application, it is due to the absence of a connection to the SIA application in the preview, resulting in the imports argument of the SM_CAT_server function being null. Nevertheless, the preview_module function allows passing inputs in preview mode. To test the module fully connected to the parent SIA application, we have to build the package from the source and install it as usual. Once we run the application locally with ShinyItemAnalysis, run_app, our module will appear in the Modules tab, as specified in the YAML file, and we can test it with the IRT model fitted by the SIA application. Now, the module receives the imports list of reactives populated by the running SIA application and is able to utilize an IRT model from the SIA application, as we will demonstrate in the next section. A standalone Shiny application is typically developed using separate UI, R and server R files, which may not necessarily be housed within a package structure. In order to migrate from a standalone application to an SIA module, the following essential steps are required. 1. Create an R package or use an existing one. In the description file, include a line containing config ShinyItemAnalysis module field set to true. 2. Within the R directory of the package, create a new R source file, e.g., SM_CAT R, which includes the module documentation, the UI function, and the server logic function. Generally, it is possible to copy-paste the existing code from the original UI, R and server R files. However, ensure that every input and output ID in the UI portion is enclosed in NS. There is a convenient check provided by the lint_NS function of the SIAtools package. 3. Create a YAML file that provides the title, category, and function bindings. For the exact structure, refer to section 3.3. SIAmodules are distributed within standard R packages, containing one or more modules. The official repository is located at https://ShinyItemAnalysis.org/repo/. Users can install these packages using the conventional install packages function and this URL provided in repo's argument. Since the repository hosts only the packages of interest without any external dependencies, users need to provide their usual comprehensive ArXiv network (CRAN) mirror to ensure the proper installation of the module packages. For instance, to install the SIA module contained in the EDU test item analysis package, Netík and Martinková, 2024a, which is not available from the CRAN, the following code can be used. Install packages, EDU test item analysis, repos equals C, https://ShinyItemAnalysis.org/repo/ https://cloud.rproject.org. To retrieve the names of already available module packages, users or developers can employ the following code. Row names, available. Packages, repos equals https://ShinyItemAnalysis.org/repo/. The developers are supposed to build their source packages and submit them to the first author of the paper via email. The sample SIA modules presented in this section may serve as an inspiration for the possible extensions of the main SIA application. Some of these modules use their datasets only, while others allow interaction with data from the main SIA application or even generate datasets to be passed into the main SIA application. The EDU test item analysis module within the eponymous EDU test item analysis package, Netík and Martinková, 2024a, is specifically tailored to accommodate the format of publicly available Czech Matura exam data. It serves as an example of how to create a customized data upload procedure that diverges from the main SIA application. Notably, the EDU test item analysis module enables users to upload test metadata specifying the type of each item, i.e., some items may follow the 3 petaliters IRT model or its restricted 2 petaliters version. Some may be modeled by the GPCM defined in equation 2, and some by the NRM defined in equation 3, wherein the correct response must also be specified. This demonstrates the capability to extend the IRT analysis within the SIA application, which currently supports only the tests with a single item type. The item-specific IRT modeling is provided in the respective tab of the module, alongside some customized traditional item analyses. Additionally, the module offers the functionality to create binary grouping and/or criterion variables from a factor variable with multiple levels, which can be utilized for DIF detection within the SIA application. The EDU test item analysis module also serves as a non-trivial case study showcasing the module to application communication. Upon uploading a dataset to the module, users have the opportunity to modify it to align with the SIA application and reuse it in other tabs beyond the module's scope. In order to be able to run all the analyses of the SIA application and its additional modules, users are offered to pass data uploaded and edited in the EDU test item analysis module directly to the main application via the Pass Data to SIA button. The CAT module from the SIAmodules package is a refined version of the simplified sample module, offering the ability to utilize models across the application and its modules. It performs a CAT post-hoc analysis, simulating respondent performance under an adaptive test with predefined settings. The DIFC module extends the DIF analysis to a longitudinal setting, detecting differential item functioning in change, DIFC, by incorporating external matching criteria such as pretest scores. This is demonstrated through an analysis of learning competencies, where despite no discernible difference in total scores between basic and academic school tracks in the 6th and 9th grades, certain items exhibit differential functioning when accounting for prior knowledge of learning competencies using logistic regression for DIF detection. The DIFC module provides an interactive and reproducible way to conduct this analysis, with the learning-to-learn dataset accessible within the main application for further analysis using various psychometric models and approaches. The SIA application, a tool for analyzing educational tests, has been enhanced with new add-on modules that expand its capabilities. These modules, developed using the SIAtools package, allow for a more comprehensive analysis of educational tests, including the detection of differential item functioning for continuous outcomes, DIFC, iterator reliability, and text analysis for item difficulty prediction. The DIFC module, part of the SIAmodules package, enables users to detect DIFC in datasets by providing an interactive and reproducible way to analyze scores and ICC plots for individual items. This module is particularly useful for researchers seeking to understand how items function differently across various groups of students. The IRR module, also within the SIAmodules package, addresses the issue of iterator reliability in the context of grant proposal peer review. It demonstrates how using subsets of restricted quality proposals can result in zero estimates of IRR under many scenarios, despite sufficient global IRR. This module is crucial for understanding the complexities of rating systems involving multiple raters. Lastly, the EDU Test Text Analysis module from the EDU Test Text Analysis package provides a tool for item difficulty prediction based solely on the item wording. This module does not require any data from the main application and instead uses text input fields and a database of item examples. It also illustrates the use of complex and large models, as well as compiled C++ libraries, making it an important demonstration of the versatility and capabilities of the SIA modules. In summary, these new add-on modules for the SIA application significantly enhance its functionality, providing researchers and educators with a more comprehensive tool for analyzing educational tests. By addressing issues such as DIFC, iterator reliability, and text analysis for item difficulty prediction, these modules offer a deeper understanding of the complexities involved in educational testing and assessment. The ShinyItemAnalysis package, an R-based tool for educational and psychological test analysis, has been enhanced through the development of add-on modules. These modules leverage the extensive capabilities and functionalities of the SIA package, including toy datasets, the option to upload custom datasets, a variety of functions, and the possibility to generate automatic reports. The EDU Test Text Analysis module, part of the SIAmodules package, showcases how these add-ons can extend beyond the data types offered in the main SIA application and seamlessly integrate with it. The SIAtools package provides a resource to facilitate SIA module development, offering a toolkit similar to JMV-tools for JMovie and JASP-tools for JASP. Unlike these packages, SIAtools operates solely within the confines of the R language, eliminating the need for a proprietary compiler or a special JavaScript runtime environment. Future versions of the ShinyItemAnalysis, SIAtools, and SIAmodules packages are expected to include direct module installation from the GUI of the main SIA application, further refining module testing, building, and submitting, and possibly incorporating module results into automatic reports. The presented version already represents a valuable extension of the ShinyItemAnalysis package, with potential to inspire and influence future projects in this domain. The study was funded by the Czech Science Foundation Project, Theoretical Foundations of Computational Psychometrics, and the project, Research of Excellence on Digital Technologies and Well-being, co-financed by the European Union. Acknowledgements are given to František Bartos for helpful comments on the previous version of the manuscript. Supplementary material, including the accompanying R scripts, is available at https://osf.io/cnbrh/. Here is a combined summary of pages 23 and 24 of the research paper. The paper cites various studies and R packages related to item response theory, psychometrics, and statistical analysis. The authors reference Angoff and Ford's, 1973, work on item race interaction and Bartholomew et al.'s, 2008, analysis of multivariate social science data. They also mention Bartos and Martinková's, 2024, research on assessing the quality of selection procedures and Chalmers, 2012, multidimensional item response theory package for R. The authors highlight the importance of iterator reliability in evaluating grant peer review, citing Arasheva et al.'s, 2021, Cautionary note on the use of iterator reliability. They also reference Drabanova and Martinkova's 2017 Detection of Differential Item Functioning with Nonlinear Regression and Hladká and Martinkova's 2020 Generalized Logistic Regression Models for DIF and DDF Detection. The paper cites various R packages, including MERT, Equate IRT, IRR2FPR, Shiny, SIAtools, and Golem, which are used for item response theory, test equating, and statistical analysis. The authors also reference Lord's 1980 Applications of Item Response Theory to Practical Testing Problems and Magis et al.'s 2010 Framework for the Detection of Dichotomous Differential Item Functioning. Furthermore, the authors mention Love et al.'s 2019 Graphical Statistical Software JASP and Martinkova et al.'s 2023 Computational Aspects of Psychometric Methods with R. They also reference Merkel et al.'s 2021 Efficient Bayesian Structural Equation Modeling in Stan and Martinkova and Netík's 2024 SIAmodules package for ShinyItemAnalysis. Overall, the paper provides a comprehensive review of various studies, R packages, and statistical methods related to item response theory, psychometrics, and statistical analysis. The authors highlight the importance of iterator reliability, differential item functioning, and computational aspects of psychometric methods in educational and behavioral statistics. The research focuses on predicting multiple-choice item difficulty from text using machine learning algorithms. The authors introduce several R packages for psychometric analyses, including EDU text analysis, which predicts item difficulty based on text features. They also discuss the significance of item characteristic curves and the detection of differential item functioning. The summary covers various methodologies, such as logistic regression and computational psychometrics, highlighting the importance of accurate item difficulty prediction for educational assessments. It includes references to several R packages and their applications in psychometric research, showcasing the potential of these tools for data analysis and visualization. The discussion on word embeddings and their application in educational assessments is also presented, emphasizing the role of distributed representations in understanding item difficulty. The summary concludes by highlighting the limitations and future directions in this field, emphasizing the need for further research in this area.